My name is Leo. I'm virtual construction manager for the Conco companies. So in my session, I'm going to be focusing more on the field technology side. So I'm going to talk about VDC more, in addition to the building information modeling part. So some background myself. So I work for a contractor, so I'm kind of more on the front line. I'm not a designer, so we use a lot of field technology, and including robotic total station layout, laser scanning, and also I'm involved in project management, like 4D planning, scheduling. The background of my company. So Conco is a commercial concrete contractor along the U.S. West Coast. So we have offices along the West Coast from Seattle, Portland to Southern California, with headquarters in San Francisco Bay Area. So a brief agenda of the topics I'm going to cover today is 3 areas. I'm going to be talking about some layout from robotic total station, laser scanning, and also 4D scheduling in the end. So layout, also is called construction staking. So I'm sure most of you have been seeing contractors start using total stations instead of, traditionally they call surveyors to provide some grid line, and you have to have your carpenters figure out the angles, the distance or sometimes you have to put tape. So on the screen you see is a structural plan, architectural plan for foundation level. So the red circle is the little porch that we were going to do the layout. So instead of calling the surveyor, I have a screenshot of we generated the shop drawing model from Revit. So we use this model for the field technician or the field engineer to do the layout. So instead of have our carpenters figure out, like I said, put the tape, so we set up total station. How it works is, if there's no lead surveyor in the room, I can say whatever I want. So basically, you got pretty good controls from the surveyor with a good quality. Then you figure out the best spot for setup with a good line of sight. So you can see the area that you need to do the layout. So basically your field engineer is holding a pole with a little prism on top. So the total station is tracking the prism. And the guide the technician to go to the direction, to the distance for the element that needs to be laid out. And the technician going to choose whatever the element on the data collector, have a little tablet with him or her. So here's a screenshot of how the tablet looks. So kind of traditionally, you can still load 2D CAD plan. So you have the line work. For example, that little porch I showed earlier, you can load those point and line work, still do the 2D, use the 2D plan to do the layout. Or, like in our case, we have a 3D model. And with the IFC exchange, most of the total station manufacturers, they support the IFC model now. So you can, some areas complicated, like you have a 3D view for the field technician, you can reduce the human errors if you take a wrong line or point from a 2D plan. Right? So in this case, you can see that little porch clearly in XYZ, even the elevation. Or nowadays, there's little layout robot running around on job site. So this layout robot has been around for probably almost 10 years, but this depends on different models. This is the one we did a demo recently, and what it does is basically the total station is tracking the prism, the little prism on top, and guide the robot, and you're going to print a line onto the surface, either on the concrete slab or, in this case, the sulfur deck. So it limits the need for snacking lines or, carpenters have to draw the lines. But I have more stories at the end of my presentation for this. Laser scan. So, in a nutshell, the laser scan is just another tool, another survey tool that collects more data compared to the total station. So you're gonna collect, dimensional data up to millions of points per second. So it generates a data set is called a point cloud. So that point cloud is so dense, it's kind of look like a model. So this is a screenshot of how it looks. So those points actually contain all the X, Y, Z coordinates. And you can do the dimensions, measure dimensions on your computer. Tied to the survey control, you can check the location and even compare to, through a model to the scan, you can compare do the deviation analysis. So I'm going to show some real-world use cases and examples from our projects. So the first is for, I call it clash detection. It's not that type of the beam clash detection. So it's actually, you scan the real world and try to find the potential conflicts between the real world and the future building that you're going to build. So in this case, this project is in San Jose, California, 4 levels down below the grade, and all the perimeter walls are sharp grade, and there are a lot of highlighters. So one of the concerns our detailer had was, the potential conflicts between the tieback blockouts to the pilaster rebar cage. So we actually performed the scan. Here's a screenshot of how it looks. So you can clearly see the tieback tab. And this scan is tied to the survey control, so you share the same coordinate with the concrete model, the construction model we have. So you throw the model back to the scan, and you can identify the areas that you have pilasters and potential clashes. And the detailer is able to trim the bar around the tieback area. So here's the actual photo after installation. So you can see it's kind of pretty streamlined workflow. So initially from the field collection, and then back to detailing, fabrication, and then go back to field for installation. But this helps a lot to look ahead to avoid any schedule delay or any quality issues in the future. Another use case from scan is, let's say, for set logistic or safety. This project is kind of 2 20-plus level towers, and you can see on screen the high voltage power lines very close to the edge of the building footprint. So we did a set scan. So same thing tied to the survey control and through the design model back to the same coordinate. So we actually identified the area that the nearest slab edge to the power line is going to be on level 5, which is going to be only 10 feet. So they helped our safety department a lot to plan ahead accordingly. This example is kind of the proactive use case from scan. So before you pour the slab, after you have your deck ready, you have the edge form opening, hanging form, rebars in, and hopefully you got your inlet in. So you do a scan, and on this screen, the blue line represents the design location of the 12 by 12 inlet plate. So those kind of yellow, red intensity color, this is a 2D top-down view looking down towards the deck. So you can kind of see the edge of the actual plate in place and do the measurement and give the feedback to adjust accordingly. Same thing in the same scan, you can see there's a core wall on this project. So any bar that you can see, and you can do a kind of a slice in the scan at the elevation of the top of slab. So the blue line is the design location of the concrete wall. So you can do measurements to make sure you have enough clearance, and if you need to adjust before you pour the slab. So post-port, if your client tell you there's some problems, if they claim the wall's out of plumb or columns not in the right location, so you can do after the formwork's being stripped, you can do a whole job site scan where you can see all the columns, the four face of the vertical elements. And nowadays there's a lot of software solutions. You can make it so easy. You put your design model and your scan together and do some deviation analysis. In this case, so instead of using totalization where you call your surveyor to check which wall, which is the bottom or the top, which area is off, you can see a whole big picture of your whole building actually. So you can tell which area is potential, they're going to be problem or not. And color is just a representation of data, the geometry location data. So it doesn't have to be in the color format. So if you need to do some numerical annotation, you can do that markups. So there's another example. We scan a wall with the inlet. So you can extract the top of the inlet elevation and inject that back to your model or Civil 3D, whatever software you use, and generate some deliverables. The last example I'm going to show for scan is quantity takeoff. It's kind of one of the byproducts from scan. So this is before a MATLAB 4. We went to the scan for checking the rebar dial location. And at the same time, you can see through the bottom bar, you can see the pad. And you can generate a 3D mesh model from the scan compared to your design top of slab surface. So comparing those two surfaces, you can calculate the volume for your concrete order. So a lot of time is more accurate because compared to your theoretical volume number from the model, because the pad is not always perfect. Sometimes low or high spot, and if you have a pit, it's always overdrive. So this is going to capture the actual concrete from the scan. So move on to next topic about the 4D scheduling and planning. So 4D scheduling planning is some people.
That's better.
So some people interpret 4D differently. In this case, I refer 4D to adding the timeline on top of 3D model. So it's actually an upgrade version of traditional scheduling tool. Doesn't matter CPM schedule or even for the pool planning. So you can see the benefit of using a 4D plan is visually tell the stakeholders, the sequence, the site logistic plan. If you show, use this for, let's say, lane closure permit, it's easier to get buy-in from the city. But many people think this 4D consumes a lot of time, which is why it's costly, but it's not necessary. As long as you have data in the 3D model, like that's the EM20 that we work on, that the BIM committee works on. If you have all those properties and data in the model, and you have your data in the schedule, and if they talk to each other well, so with some data mapping, this 4D model can be done. A lot of automation can be made to make it easier. Another use for 4D sequencing is to communicate your plan, and it's easier to interpret with your client. So this is one of the projects in downtown LA, which was finished, I think, 2 years ago. So we use this tool to show the client our plan for the last few levels, how we dismantle the planning system, how we pour the last slab on metal deck, and with the slick line, and how we plan to pour the last parapet wall with bucket and all that. And also, any data in your schedule can be loaded. So by using this, you can show your quantity projection from the model, or if you load your resource, manpower, all those data can be visualized with the 4D sequencing. This is better for communication that way. So terminology of BIM has been so long, and virtual design construction, VDC, it comes after BIM, but that's also widely adopted everywhere. But I'm sure most people heard other words like digital twin. Some people say a scan or 4D plan or the structural analysis model, that's the digital twin. And other words like Industry 4.0, AI now is everywhere. I just show some examples of the word, and 2, 3, 4, 5, 6, you name it, how many dimensions. So are they really buzzword? Well, in my opinion, they not, but they exist to improve our, the efficiency and productivity, the way we work. So, and that's how they push the industry forward with those new technology. So the last but not the least, and go back to the story at the beginning, this little robot, so we did a demo. So the main concern is the accuracy and precision. So we checked that with the totalization. As you can see clearly there's a right line on the picture. That's printed from the robot. And the green dot in the white circle, that's actually from the totalization. So it's just right on the money. So you can see the precision is very good. But what you don't see is on the backside. There's actually 3 guys lifting the bar to help the robot to clear some clearance to the bar. So my point is, technology, innovation, they are great, but it has to set its boots on the ground, and it has to refine, iterate to actually solve the real world challenges. So.